Hi, I am Karthik and Ranjan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
Hi, I am Karthik and Ranjan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me, so I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
Hello, everyone. I hope you all are doing good and you are ready for our next session. Okay, so I hope my screen is visible. So let's start with a recap of our previous session, which was the current banking flaws, such as the middleman transaction fees, the slow transaction speeds of banking systems, and it being centralized is prone to corruption and human errors. So we also learned what is blockchain technology. So blockchain technology is a cloud storage technology where the information is stored in the digital ledger technology, which is a kind of database system where all the transactions are recorded in form of blocks. So what are the advantages? We talked about the advantages of blockchain over the traditional database system, which were it is much faster, it is decentralized. Decentralized means there is no single governing authority or entity controlling the blockchain network. So, if we are not controlling the blockchain network and everything is based on smart contracts, so there is no chance of human error, because once the conditions are fulfilled, the smart contract transaction will be executed. Again, what are smart contracts? Smart contracts are kind of brain of the blockchain. Uh, this is where most of the job roles come into the place as a smart contract developer. Smart contracts are a piece of code, snippets written in Solidity programming language, sometimes written in JavaScript as well, also Golang. We talked about consensus protocols. We'll be diving deep into it later. We talked about the proof of work consensus protocol that Bitcoin uses. And we talked about Bitcoin and Ethereum, how they work, and we'll be talking more about Ethereum because Ethereum has upgraded over the years, and they have actually combined. They do not run on a single consensus protocol. They run on two consensus protocols, which is proof of stake and proof of work both. So it is a hybrid version, and the name is called Casper. We talked about exchanges. What are exchanges? Exchanges are where we can buy and sell our cryptocurrencies on. Wallets are where we are store our cryptocurrencies and access decentralized applications. Now, crypto mining. We didn't get into the detail of crypto mining, so let's start with the detail. Understanding crypto, how does crypto mining work? Although it is not much profitable right now, even if you use natural energy resources like windmills or solar panels, but they are not much profitable. Okay. So I think most of the computer science students are familiar with the computer hardware, but those who are not aware of it, let us talk about computer hardware a bit. So there are graphic cards, different kinds of graphic cards, such as 3070, 7900 XT, 70 900 XTX, XT 7800 XT. So what are these? These are basically graphic card models. 3070 series and 4080 series, these are manufactured by NVIDIA, and these 7900 series is manufactured by AMD. So these are the only two companies who manufacture graphic cards. There is Intel that manufactures graphic cards. It was discontinued, but it still offers some of server-based graphic cards. So this is a website called whattomine.com. Here you can select if you want to build a mining rig. For example, let us take the latest graphic cards like 4070 Ti. And if we are adding 10 graphic cards to a mining rig, we will calculate the power. Such. Okay, so 10 graphic cards, 4070 Ti, they almost cost like 90,000 rupees or 1 lakh rupees per graphic card. So it is a costly setup. So yeah, you can mine these coins. This is the algorithm. The profitability is good on these coins. That is when the cost of electricity is this. But this is not the case in India. The cost of electricity also varies from cities to cities. So it is not that profitable. Even if you like set up the mining rig, and with the initial cost would be much higher. You just this is just for information. You can just connect your wallet and run this script. It is giving a good ROI, good percentage of ROI. Yeah, so this is the difficulty. This is uh, the fees. And the concept of gas fees is that I forgot to mention in the previous session that uh, these miners are mining cryptocurrencies, right? These miners are providing their computational power to run transactions for the Bitcoin or the blockchain. So these gas fees are the rewards for the miners. This gas fees doesn't go anywhere else. This gas fees is for miners. So every transaction, we have to pay a gas fees that is paid to a miner who is providing his computational power to run the blockchain itself. So that is how you just have to run this script. Go to this website. Start building, start mining. So solo mining guide, this is a miner wallet. You can create your new wallet or add a MetaMask Trust wallet or already available wallets. Uh, you list your miner address. You will add your wallet name where the cryptocurrencies should be deposited, and you just have to run the script. Start mining, and there are different instructions for NVIDIA graphic cards and AMD graphic cards. And I can tell you something. I can tell you something like you have to connect the graphic cards to get the most hashing power. See, the more the hashing power there is, the more the rewards will be. So you have to adjust the graphic cards in a way they provide you the best hashing power. And this is generally achieved by lowering the GPU frequency. For example, you see that your computer frequency, I'll show you. Let me share my complete screen. This is better. Okay. Yeah. So this is the hash rate, and hash rate is generally calculated in gigahashes per second or mega hashes per second. It depends on the power of the GPU. So highest hash rate gives you highest computational power, and it provides you better amounts of rewards. And this is generally achieved by lowering the frequency of the graphic card by using an app called MSI Afterburner. Some of you might have already used it. You can underclock the CPU frequency, like the GPU frequency, and you have to increase memory clock. So as long as the graphic card is stable, it will provide you the best hashing power and provide you the best rewards. Yeah, okay. So with that, we let's end the crypto mining discussion. Crypto mining can be done even through your mobile phones. There is a project which was developed by Stanford students, but it has been on the test net for like 3 years now, and it is not live. I won't name the project. Let us talk about cryptography in blockchain and ZK Snark EVM rollup. So, what is cryptography in blockchain? Basically, it is the encryption and decryption part. How the encryption and decryption happens in the blockchain technology, because it is different than what the current systems are using. We can take WhatsApp as an example. Every one of you uses WhatsApp, right? So many of you might have seen that for some chats, you might have seen there is the security code that is changed between you and this other person. So that is actually your secret key. If someone gets access to that secret key, he can encrypt all your messages and his messages as well, your contacts messages. So the data leakage is at both the points because you both share a same private key. We'll get into it detail. Let us first understand what are private keys. Now, a public and private key is basically used to decrypt the messages encrypted in a mathematical algorithm within the cryptography methodology. The main differences between the private and public. I have tried to keep the slides a little text heavy so that it is helpful for you to read something later on, but I'll try to explain it in my own sense. Yeah, so main difference between private and public keys is that public keys can be shared with anyone, and private key is to keep it secure. So your private key is something like it is something like A, B, C, D, 1, 2, B, E, F. Generally, you see those kinds of encryptions in that WhatsApp messages. Uh, and when there is topologies, if you are not aware of the topologies, there are different kinds of topologies when communicating. So this is a one kind of topology where I'm the one person connected with you all. So this is one to many topology. And if you all are connecting with me, talking to me, and that would be many to one topology. So the biggest difference between the private and public key is that private keys are meant to be kept secret and public keys are meant to be shared. Now, this key is a sequence of random symbols available to any person, public key, and it can be decoded by the private key. The public key is used for encryption, but only the private key can help you decrypt the information. In case of, let's say, just take WhatsApp as an example, and let's take another app called BChat. Okay, so there is another chatting app called BChat app available on Android or iOS store. It is a Web3 messaging service. Once you download it, you won't have to enter any of your private information, such as your name, your email ID, or anything. It will just act like your wallet setup is done. I'm sure you must have done wallet setup. You all have installed the MetaMask and Trust Wallet. And if you have done it, you can see, you might have seen that secret phrase it might have given you. That phrase is your login credentials. So that is your private key. And the public key would be the address of your wallet, which can be shared with anyone to receive cryptocurrencies. So just like logging into your email, you need a password. The email password is another email network participants to send messages, while the password is required to access the email account. However, for the longest time, symmetric key encryption. So this is the symmetric key encryption that is used in the WhatsApp, where the secret key is changed between the users. Not changed, it is changed, which is called cyclic redundancy checks. So your private keys are also changed every like 2 weeks or month. So it enhances the security. But the symmetric key encryption is way much faster than asymmetric key encryption, which blockchain uses. Okay, so the differences between public keys and private keys, both private and public keys, goal is to verify that a given transaction was spent by the party who signed it and not forged out of thin air. Though both types of encryption cater a similar purpose, they differ in many ways. Here's what you need to understand. Algorithm and mechanism. In public key encryption, there must be two separate keys. So in public key encryption, which is the asymmetric key cryptography, there must be two separate keys for encryption and decryption. The private key is for owner only, while the public key is available to anyone. So one key is required for transmission between the two parties involved in symmetric key cryptography. The same private key is used both to encrypt and decrypt the information. It is shared between the sender and receiver of an encrypted message. So when there is a shared private key, it becomes symmetric key cryptography, which is used by WhatsApp. So you might have seen WhatsApp chat leaks, right? There were some news about WhatsApp chat leaks. Now, how do you think that these chat leaks happen? These chat leaks happen if someone gets access to your private key. He can decrypt, even if I can get your private key for the WhatsApp accounts, I can easily decrypt all your conversations. But this kind of cryptography is much faster. Privacy, let's talk about the privacy part. The private key is kept secret and not disclosed to anyone apart from the wallet's owner. Once lost, the private key is impossible to restore. Now we are talking about the wallets encryption and decryption part. So the private key is kept secret, which is your secret phrase when you set up a new wallet. Let me set up a new wallet right now. That will be better. Let's create a new wallet. MetaMask, forgot password. This is not working. Let's use Coinbase wallet. Install. Activate. This is a Web3 browser as well. Brave. This is called Brave. It can use Google extensions, but it has no trackers. So it doesn't send reports of Google Analytics to others. So your privacy is maintained. So this browser is available to everyone, even for Android and other devices. Why is it setting? Hmm. Now, we can even import a wallet by providing our secret key or create a new wallet. Now here, set up a password. Mhm. This is just for additional privacy and additional security. I'm just adding it anything. Yeah. So the mnemonic phrase is your wallet's password. Okay. So this is my secret key. I can forget my password. That won't be an issue. But if I forget this, I cannot recover my account. So this is very important. This is not to be shared with anyone. That is why I'm creating a new wallet right now for you to understand uh, what is this. Now, backup later because I don't care about it. This is just for demo. Now, here is our wallet. Now we can connect this wallet. Connect this wallet. Still not- Yeah. So this is a digital signature. We are doing a digital signature through our wallet app. So I agree. Welcome to OpenSea. Accept and sign. And yeah, here we go. The green light. We are connected. And now we can even list any NFT. I'll show you that process as well. I just won't list an NFT because it will require a little bit of gas fees. That is not much, but still. Yeah, so we can go to create, maintain NFT. For example, I can let's upload XLR's logo. XLR. Now this is the supply part. How many of the NFTs we want? How many NFTs we want to mint? So if we increase the number, it decreases the rarity. But yeah, let's offer 1,000 XLR logos. Just XLR logo, and we can add external link to like XLR's website, and we can just go ahead. Yeah, we have to create a new collection as well. So this is much cheaper. The gas cost is 0.02. Let's see more options if there is any free option. Estimated cost is high. Arbitrum 0.01. So this is the cheapest one. We should always go for the cheapest one, which uses lowest gas fees. So we can choose this, and or we can choose Polygon as well. This is also cheap, and it is much more popular. That's XL token symbol EXL. Drag and drop. Okay. So this is the logo. Create. Now we are deploying it. Now the contract has been deployed. Confirm. Now I don't have the gas fees because I just set up a new wallet, but it is almost a negligible amount of gas fees. Earlier it was free, so I could have just shown you how to list an NFT, but this is the process on how you can list an NFT and earn money from it as well. Even one of my students sold an NFT for like it was like for 6 Ethereum. Uh, that is almost 10 lakh rupees. So a student sold the his first NFT for 10 lakh rupees. So that was really amazing. That was really great. This is to empower artists. But we were understanding how wallets work. So now if we want to, not receive, we want to receive. Now, if we want to receive any Ethereum, let's say Ethereum, uh, okay, yeah, let's receive Ethereum. So this will be my address. I can share this with anyone. This is my private key. In case of the blockchain, this is our public key. We can share this with anyone, and no one can decrypt it because only your private key can decrypt the data. So there is only one endpoint of data leakage instead of two endpoints, and your private key is safely secured in a offline environment. So what is the price of Ethereum right now? So it is around 2,300. Yeah, $2,300. So these are all main nets. These are different kinds of nets. ZK, Syncera, Avalanche, Manta, Pacific, ZK, Bitcoin, Ethereum. We can also add a network. We can EVM. We can add EVM network. When deploying tokens, we can also add native token support. Uh, we can add it from accounts, Bitcoin testnet, Bitcoin Classic. So BSC testnet, Blast testnet. There are many testnets as well. Yeah. So for example, if we are using Goerli testnet, we will select Goerli testnet, and we can actually receive our created tokens in our Ethereum Goerli test network. We'll do the complete practical when we will deploy our first smart contract uh, on the Friday session, last session. First of all, let us understand what is the cryptography methodologies used by blockchain. So there are two different keys. There is one public key and private key in asymmetric key cryptography. Digital signature, I just showed you what is a digital signature. You can just digitally sign your, uh, just give me a minute, please, sorry. Yeah, sorry. So I just showed you what a digital signature is. You can just log into your wallet, and your wallet will act as a digital signature for the smart contract interaction. Yeah, I see two raised hands. If you have any questions, you can share it on the chat. So encryption and decryption is basically the security methodology to secure your information. So the no authorized access, unauthorized access is possible. Confidentiality is achieved by using private key that is known only to its owner and nobody else. So the encryption process with the secure public key guarantees that the received message is not altered. So there are different kinds of encryption and decryption processes, such as digitally signed PDF files, Open PGF, PGP, SMIME. There is SHA 256. This SSL protocol is used in web. Then SSH. Uh, so we already talked about mining. Let's skip this. So cryptography is both art and science, referred almost exclusively to encryption, which is the process of converting ordinary information called the plain text into unintelligible gibberish called ciphertext. So cryptography is all about encryption and decryption. The encryption and decryption, what is the what are the advantages of encryption and decryption? It achieves confidentiality, It also helps us out with authentications, just like we did it right now. Integrity through generating a digital signature with a public key and obtaining the message digest, then hashing the message to obtain a second digest. If the digests are identical, the message is authenticated and the signer's identity is proven. So what are digests? These are just hash digests. We previously talked about uh, the unique ID of a block in a blockchain. So non-repudiation through digital signatures of a hashed message, then encrypting the result with the private key of sender, thus binding the digital signature to the message being sent. So non-replay, obviously through encryption and hashing and digital signature. So there are two types of encryptions, symmetric and asymmetric. So this is the working of a symmetric encryption. There is a shared key. This is plain text, anything. And then this is then encrypted using the shared key. And this is then turned into ciphertext, which is the gibberish. This is then sent to the other person, where he will use his private key to decrypt the ciphertext, and then again he will get this plain text. So in WhatsApp, you see the conversations are end-to-end encrypted. That is what they mean. They use symmetric key encryption. They use the same key encryption. So they can just decode, you can just decode all the information if you obtain the shared secret key. So the most widely used symmetric encryption method is the block ciphers triple data encryption standard 3DES. Triple DES developed from the original, and now cracked DES uses 64-bit consisting of 56 effective key bits and 8 parity bits. We don't need to get into the detail of this. We have the problems with symmetric encryption is symmetric encryption, although fast, I told you it is much faster because there is only one key, but suffers from several problems in the modern digital communication environment, including the biggest problem, that of a single key that must be shared in pairs of each sender and receiver. So there are so many keys, so many private keys in WhatsApp. Like for every contact, you have a different private key. So you will have to distribute a large number of combination pairs in many to one communication topology. It is difficult for the one recipient to keep so many keys in order to support all the communication. So in one to many topology, as I'm doing right now, I'm speaking and you all are listening it. So in this kind of topology, I will have to maintain a secret key with you, uh, with each one of you, which is very difficult. The size of the communication space presents problems because of the massive potential number of individuals who can carry on communication in a many to one, one to many, and many to many topologies supported by the internet. For example, the secret key cryptography, if strictly used, requires billions of secret keys pairs to be created, shared, and stored. So there will be billions and billions of shared keys, private keys. So this is a problem with symmetric key encryption. It is faster, but it is not that secure. Main thing is to notice that it is not that secure. It is faster, but not that secure. Now let's come down to public key encryption, how it happens. So the public key encryption happens like this. Uh, your private key decrypts it to, sorry, the plain text is encrypted through the public key and it is converted into ciphertext. Then it is sent to the other person who uses its private key to decrypt it to plain text. So this is public key encryption. Public key encryption commonly known as asymmetric encryption. So this is asymmetric encryption, which is used in blockchain technology. So the biggest example is wallet. So you have a public key to send or receive cryptocurrencies, and then you have a private key, which is your uh, security phrase. We just saw that while setting up our wallet. So cryptographic hash functions. A cryptographic hash function is an algorithm that can be run on data such as an individual file or program to or a password to produce a value called a checksum. So you must have heard about checksum. Uh, s- uh, mm. So you must have heard about MD5 checksum. Generally, when you install programs and you need to check if it was correctly installed, if it has the correct cryptography mechanism. For example, right now, let me show you. For example, let's go to Google. Now, I want to download Firefox. Okay, so now this is the official website of Mozilla Firefox, but there are other websites which are offering the same software. So we need to make sure the encryption and decryption is right. So how will we do that? We will actually download this software and then we can check the encryption and decryption method by like going to here and properties, security, advanced. Okay, this is not a program. Python. Yeah, so digital signature. Yeah. So here we can see this uses SHA-256 256 encryption methodology. So these are different kinds of encryption methodologies. This is just an example for you to understand how cryptography works. And this is the normal cryptography, but the blockchain uses asymmetric cryptography, which is a little slower but much more highly secure. So, cryptographic hash function use case, I already showed you. You can download Firefox Fox browser. It will show you SHA-2. For Python, I showed you it. The encryption was SHA-256. So that's it. That gives you an idea that you downloaded the correct version and not a modified version where someone else is able to access your information. So yeah, that is why we always recommend downloading softwares from their official websites, and these third party websites which offer softwares, they are generally not safe. They ask for permissions, which uh, threatens your privacy. So defining symmetric encryption, we understand that in symmetric encryption, data is encrypted and decrypted by the same secret key, whereas the asymmetric key encryption uses a more complicated process where we use two different keys but mathematically related keys, one public, one private, to encrypt and decrypt data. So, yeah, when we are sending cryptocurrency, for example, so when we are sending an cryptocurrency, our our private key will uh, uh, encrypt the data, and the receivers our public key will encrypt the data, and his private key will decrypt the data. So what are the main differences? Main differences are that symmetric key uses one single key, asymmetric uses two keys. Symmetric key encryption uh, uses shorter keys, usually 128 or 256 bits, but asymmetric keys are longer, much longer, 2048 bits longer. So look at the difference in bits. It is much longer and it is much more secure. However, although symmetric key encryption is faster, we already talked about it. It is much more faster. There is not much to talk about it. Let's talk about zero knowledge proof. So we will begin by covering. Uh, just give me a minute. Sorry. Yeah, so I'm really sorry. That was a work-related call. I had to take it. So we will first understand what is zero knowledge proof. So what is zero knowledge proof and what is Ethereum virtual machine before we dive into ZK EVM rollup. So this was a EVM rollup done by this was ZK Snark done by Basically, this was done to increase the scalability of the blockchain, because there is a problem of scalability in most of the blockchain projects. So this is very important, zero knowledge proof. So and Ethereum virtual machine as well. Before diving into ZK EVM, a general purpose rollup that uses EVM as its smart contract engine while remaining compatible with the applications live on Ethereum ecosystem. Let's get going. What is a zero knowledge proof? So zero knowledge proofs are cryptographic algorithms that allow users to authenticate the legitimacy of a transaction without providing any information about it. So this is accomplished by creating a digital signature that may be used by a third party to validate the transaction while concealing all sensitive information. So what is Ethereum virtual machine? So Ethereum virtual machine is kind of a platform where you can deploy your smart contracts. It acts as a interface to run your smart contracts. So Ethereum virtual machine is developed in Solidity, which I told you earlier. It is the programming language used by Ethereum, an Ethereum specific programming language. It operates as a runtime environment for smart contracts and decentralized apps. It is basically in charge of processing and confirming the transactions on the Ethereum network, keeping track of the network state and making sure that everyone adheres to the consensus guidelines. So we talked about the consensus as well. So it will take care that it is following the consensus guidelines, and it will help us uh, validate the transactions through digital signatures that are used by our wallets, just like I showed you. So EVM runs continuously and maintains the status of each block in the Ethereum blockchain. EVM sets the specific rule of updating state from block to block. So basically, EVM is just something to deploy your smart contract on. We will be deploying our first smart contract as well. I'll show you the compiler used for it. So as the EVM code is the same across all nodes, the failure of a single node does not impact the system. So the EVM code is almost the same in all nodes. And we are talking about public blockchain here. We haven't dived into the private permissioned or the consortium blockchain, because the biggest difference between the public and private blockchain is that in public blockchains, all nodes carry same information, whereas the private permission blockchain, all nodes carry different information. So what is ZK EVM and how does it work? So ZK EVM, or zero knowledge Ethereum virtual machine, allows for zero knowledge proof computation and enables the execution of private smart contracts on the Ethereum blockchain. It combines the Ethereum virtual machine capabilities with the privacy preserving properties of zero knowledge proofs. ZKVM works by allowing developers to build and deploy zero knowledge smart contracts on the Ethereum network. Again, we are using a third party service here to deploy and deploy our smart contract and to communicate with it. We are using a third party service. This means that the variables like the contract inputs, outputs, and computation remain private to the network while being verified by the Ethereum nodes. So we can easily use ZK EVM zero knowledge to the Ethereum virtual machine that allows authentication using digital signatures, and ZK EVM does this by utilizing ZK snarks as sort of zero knowledge proof that allows the verification of computation without revealing its inputs and outputs. So it will not reveal any input or output. It will just act as a verification point where users can connect with their wallets and just digitally sign it and go ahead with whatever application they want to use. ZK-SNARK is a cryptographic proof system that allows one party to prove to another that a statement is true without disclosing any information about the statement. So what it actually does is it will not disclose the information about the transaction itself, but it will authenticate, and it will be kept secret, the transaction. So when a smart contract is run on EVM, it is first converted into a circuit which is used to construct a ZK snark proof. This proof is made up of two components. Again, one public key and a private key. The private key is kept private by the person who created the contract, and the Ethereum nodes utilize the public key to validate the proof. Again, this uses asymmetric key cryptography. So how does ZK-SNARK generate proof? Let's talk about that. ZK-SNARK uses advanced mathematical functions and algorithms and encryption techniques to provide proof that a computation is valid without giving any information about it. It follows a procedure known as trusted setup, which involves generating a set of public parameters that are shared by all parties. So what are these parameters? We will, for example, we can set parameters that you should be able to connect to these networks. You should hold this amount of cryptocurrency in your wallet, or you should be able to you should be able to connect to DApps using different networks. Just like I showed you, there are different networks in the wallet app. So there is a lot to learn. I'm skipping some of the things, I know, because obviously there is limited time to given to me. So in which I have to provide you the best possible training. So yeah, we won't dive into details of this. We can just set the public parameters, and it is shared by all parties. And these parameters are generated using a complicated multi-party algorithm, which assures they cannot be altered by a single party. We will be using this in a project at the final session. So when we do this, you will understand it more. When we do it in a practical way, it is much better to understand. Once the trusted setup is complete, a prover can utilize the parameter to construct a ZK snark proof, which includes a concise cryptographic proof and a verification key. So mainly it works as a third party authentication system. So what is the main difference? What are the main features? Execution uses zero knowledge proofs to execute smart contracts directly execute smart contracts, security enhanced security owing to use of ZK proofs. The security is based on deterministic execution, scalability, as the transactions are bashed together. Hence, it is highly scalable, limited scalability due to gas fees. So, what we understand from it is that we already talked about asymmetric key cryptography. It is slower. Why is it slower? Because it uses two keys. And because it uses two keys and there are many topologies, one to many as well. So to keep to keep track record of so many keys, the scalability loses down. We cannot scale the projects because as the number of user base will increase, the keys will increase and the traffic will increase, and the nodes wouldn't be able to handle all that traffic. Also, when there is so much network clogging up, the gas fees gets higher. So this is why ZK-EVM is necessary. ZK-EVM sorts out those things such as scalability because it acts as a third-party authenticator. It will just use your digital signature and just give you the access to the decentralized apps, and uh, and anyone can easily access it, and you don't have to store a large database of keys because storage requires costs. High storage means high costing. So it is highly scalable, and it also offers privacy. It preserves privacy of the transactions also, and no native privacy features are used in this. Scalability is one of the primary benefits of ZK-EVM. It enables privacy preserving computational scaling, which is not achievable with EVM as it has gas fees associated with executing smart contracts. So yeah, the digital signature removes that gas fees, and we can easily interact with our smart contracts. So who is building ZKVM rollups right now? Polygon is using ZKVM. Polygon, I told you, Polygon Matic. This project is developed by Indians. This is by India, and it is a layer 2 protocol and scaling solution. Layer 2 are basically scaling solutions that aims to make EVM equivalence. It allows for frictionless scaling as it enables developers to copy paste code which is compatible with Ethereum and use it to build on Polygon ZK-EVM. So we can also use Polygon as a base, which is already a layer 2, and we can also build a framework on top of it. So it makes it easy for us developers to make projects on blockchain which are already compatible with Ethereum. So Polygon has already gotten around like 84K plus wallets, 75 plus ZK proofs generated, 5K plus smart contracts have been deployed on it. And this is the cost of generating a proof for a large batch of transactions. See, why this ZK-EVM is necessary. This ZK-EVM is necessary to reduce these gas costs. Only two things. Number one is scalability. Number two is the gas cost. So for a large batch, this is the gas fee. Otherwise, for a single transaction, you can expect it to be around like $1 or $2 also. Now, is another project that is using ZK EVM. Scroll is a ZK rollup built on top of Ethereum. It is also built on Ethereum layer 2 protocol. To scale it, it consists of two major pieces, the ZK EVM, which proves the correctness of EVM execution in layer 2, and complete L2 layer 2 architecture around it. By February 2023, they had processed over 15.4 million transactions. It has submitted 1.8 million proven blocks with over 641K validity proofs, which have been finalized by their rollup contract on layer 1. Their alpha testnet is currently live on Go Early. So their testnet is live, alpha testnet. I showed you the Go Early testnet networks. We'll be talking about that when we are actually deploying the token. We will write a smart contract. So Scroll is currently valued at 1.8 billion US dollars with its recent fundraise of $50 million from investors like Polychain Capital, Sequoia China, Bain Capital. So the conclusion is that ZK EVM is a novel technology that combines zero knowledge proofs and the Ethereum virtual machine. This allows for the safe and effective processing of confidential data on the blockchain. It is a radical solution that might completely change how blockchain technology is applied. ZK EVM possesses enormous potential to empower blockchain technology to support a wide range of applications with its ability to improve security and efficiency, promote transparency and scalability. So mainly ZK EVM was developed for faster transactions, lower gas fees, and faster authentications. Now let's talk about some good projects like layer 1, layer 2 projects. Near protocol. The OS for an open web. So Near protocol is a layer 2 protocol. Uh, this uses JavaScript, which gives you a familiarity. The browser I'm using is Brave. This is a Web3 browser as well. And you can actually receive cryptocurrencies for watching ads in this browser. You won't see any ads in this browser, even if you use YouTube or anything. Okay. Now another is Solana. So Solana, you can also build projects on top of Solana. I already told you uh, I already told you that Layer 2 protocols are much faster using ZK EVM rollups as well, and they are more scalable and they require lower gas fees. So now if we want to build it, what is the programming language here? The programming language here is called Rust. So we are not going to dive into Rust. We'll be focusing mainly on Ethereum. But you should know like what kind of programming languages are there for different uh, environments or developer platforms. Also, we talked about private permission blockchain, right? So let me show you what is private permission blockchain. Let's discuss about that. Okay, so let me open an app. Okay. So this is a product. Let's say this is anything, stone or anything. Let's say it is a PC, or let's say it is a tablet. It is a tablet. Okay. Now this is bank. This is your logistics team. LOG. Okay. This is your logistics team. This is bank. This is your marketing team. And K T. This is your retail shop. This is your retail shop. So these are basically nodes. Okay. These are nodes. These are different kinds of nodes. But if we use the public blockchain here, do we want to, this is our product. Let's say this is a tablet. We are a tablet manufacturing company. We want to take a loan from bank, and we have a logistics department which sells the products and ships the products which we get through online, and we have a marketing team with a marketing budget, and we have a retail store where we also sell our tablet. So we will be taking a loan from bank. We have to manage the logistics as well. We have to manage the marketing as well. But we don't want bank to know that what is happening in the logistics, or we don't want the logistics team to know what is happening, like how much amount of loan you are taking, or we don't want the marketing team to know how much loan you took, or we don't want the retail shop to know about your online orders. So that is why the biggest difference between a public and a private permission blockchain is that these nodes interact differently. While the public blockchain, all nodes verification, all nodes interactions are same. So all nodes will interact same, and this is used in enterprises only. This is used in enterprises. Okay, so this is used by basically enterprises, uh, and the development platform for this is Hyperledger Fabric. So you can also, they have very good tutorial videos, like they'll show you how to code, they'll actually tell you how to do everything. And this is open source project. There are different components as well, such as Aries, Besu, Iroha, Firefly, Indie, Sawtooth. So this Hyperledger foundation is used for making supply chains, because in supply chains we don't want everything to be transparent, right? We do not want to work with anonymous people in an organization. You don't want to work with random people, you want to work with trusted clients. So for a software that runs blockchain technology, for example, in a college setup, for example, you can make a supply chain where all attendance are added, all the scores are determined, and everything is done and managed on the blockchain itself. The results are given, uh, the tests get the tests, the assessments are automatically checked. So things like that. We can even integrate different kind of technologies with blockchain, such as Internet of Things. We can integrate AI into our blockchain. We can integrate JavaScript. Uh, Actually, the smart contracts are not called smart contracts in Hyperledger. They are called chain codes. So the main tough part of Hyperledger Foundation is only environment setup. And once if you try to actually try to set it up, uh, you will take only 1 or 2 days to learn it. And once you set it up, you can easily use your JavaScript for development. People are already familiar with it, and these are different components. Why are these components available? Because it depends what we want to do with our project, right? So every component offers different kinds of features and different kinds of consensus protocols as well. So already these big companies, Accenture, IBM, Deloitte, Fujitsu, the Kaleido, these are Bosch. So they are all using blockchain technology supply chain. So yeah, they are helping a lot. But before we work on this, we'll be focusing on public blockchain. So let's get back to Ethereum. So you can see the white paper of Ethereum. What was the history of the Ethereum and Bitcoin. This is inspired by Bitcoin. Earlier you could also mine Ethereum. You can even right now mine Ethereum, but the difficulty and the profitability is too low. Difficulty is very high, profitability is low. So yeah, Merkle trees. So what are Merkle trees? Merkle trees are basically a proof for validity that these transactions happened. So they happen in trees. And when these trees have unique hash digest and if some nodes work incorrectly, they can be called upon using the hash digest. Okay, so earlier Ethereum used to work on same consensus protocol as Bitcoin, which was proof of work. You could mine Ethereum directly into your wallet by running the script as I showed you earlier on whattomine.com. But there are better ways to make money. The mining part, the Ethereum accounts, code execution. So they provided code execution, which is code execution platform, which is Ethereum virtual machine. So decentralized file storage. This is actually the decentralized file storage. We can also build Google Drives, which are decentralized. Mean drive software, which is decentralized. So yeah, these types of products will be really will be really the norm in the future because we have seen that Google Drives and other drives are sometimes hacked and the important documents are lost. So decentralized file storage will help us here. Mining centralization. So how it is, it also uses SHA-256-bit encryption, ASIC miners. I can show you, I forgot to show you ASIC miners. Let me just show you. Where were we? Mine.com. Yeah. So you see here ASIC. So these are basically different kinds of miners and these are different kinds of scripts. SHA-256, this is for Sia coin. This is Lyra, and you can see here like what is the market cap of these scripts. Keepa, Sia coin, like this is the most oldest cryptocurrency, I think, that is still working. Uh, this is almost as old as Ethereum. So yeah, this will be the best coin here when mining with a ASIC miner. And these ASIC miners are basically just machines. I'll show that to you as well. So yeah, these are available on Amazon like this. These are the ASIC miners. They will tell you which scripts they can mine. This is a Litecoin miner. So in 200 rupee, $200, you can get a ASIC miner which mines Litecoins, and you just have to connect it with your wallet and run the script. This is very easy. I did that mining thing back in like 2016 or 17. So yeah, this is very easy. Mining part is very easy. But why do you think Ethereum has shift? Sorry. So why do you think Ethereum shifted its protocol? It was originally working on proof of work. So why did it shift to proof of stake, like a hybrid version of proof of stake? So they did it because when providing computational power, it requires a lot of electricity. It also like generates a lot of carbon footprint. So to remove that carbon footprint and for better environmental friendly ecosystem, they shifted their consensus protocol to proof of stake. But proof of stake is basically where you can stake your cryptocurrencies to earn rewards. So let me just show you stake Ethereum. So now you can stake. This was not available uh, mm, around like September of last year. Yeah, 2023. So when the ETH merge happened, after this Ethereum merge, you can now stake Ethereum, and the current APR is 3.4%. So there is no point in investing in this and staking on this. But yeah, they are offering this feature. And you can actually utilize this feature if you are a believer that Ethereum's price will go up high. So getting even small amount of returns will result in dual returns. But I would say if you really want to invest in it, go for PancakeSwap, which is a decentralized exchange. I showed you on farms. So when you do this kind of farming, let's say this is the best pool that is offering you, no, this is the best, which is offering you the most returns. But we don't know what PNP coin is, and this is probably a new coin. and the staked liquidity amount is also low. So here we can see the liquidity amount is high, the multiplier is set at high as well, and we know USDT is a stable cryptocurrency. So even if we buy it right now, USDT will result in profits because rupee has been falling down for the last so many years that I've been seeing. So last time I remember I bought USDT at 60 rupees. So now USDT is also on 90 rupees. You get dual profits, and even if the cryptocurrency's price go down, you are going to get 93.71% in returns. So even if the price goes to zero for the cake part, you will still be getting rewards. You will still be in profit. So this is very beautiful. This is like proof of stake is made, is actually, you can say, it is made for rich to be richer. So the bigger the investment amount is, you can earn more. This is also a kind of mining. You are just locking your cryptocurrencies for transaction fees. This will be used as transaction fees, and you will be provided with new tokens. So we have covered cryptographic hash functions, cryptography, ZK EVM rollup. We have talked about a little bit about proof of work and proof of stake as well. We have talked about Ethereum and the Ethereum's major upgrade, which was the Ethereum merge ETH 2.0, which offered these kinds of services: staking, home staking, staking as a service. You can run your node with by buying 32 Ethereum, and then you can get even more percentage of interest on of rewards in your wallet. Then there is pooled staking. These are generally terms similar to those in stock exchanges. So run a node. I showed you how to run a node. You just have to download Geth software and it will run a node. Now, what are DApps? Let's talk about DApps. So I want you all to please explore decentralized application, different kinds of decentralized applications, as I won't be able to cover every project in detail, but I'll try to cover major projects, all the major projects, but still, please do explore decentralized applications because there are a lot of them. So I can tell you that this is for finance. We already talked about this is a DeFi and this is also a decentralized exchange. OpenSea. OpenSea, we already opened it. We connected a wallet with it. This is an NFT marketplace. You can buy, sell, and trade metaverse lands as well as NFTs and everything. Now, Gods Unchained, this is a gaming DApp. So you can earn cryptocurrency and you can actually earn money by playing this game. So you will be earning cards which you can sell further. There is Ethereum name service. This is also another project. Uh, what it does, it you can see it offers you domains. So whatever domain you want to. So for example, uh, launch app, search for domain. So XLR. So XLR.eth. So if I pay 10 years of gas, this is the amount in Ethereum. In USD, it costs me $17, which is less as well. And this domain will be Web3 domain. This will be a decentralized domain. And the website we will build will be called a Web3 website. Similarly, there are Web3 websites such as, let me show you, Cointelegraph. So this is the biggest magazine, or you can say news coverage channel for Web3. And this website, even though their domain is not on Web3, but their website is actually based on Web3. Um, Let me show you what I'm talking about. Let's open any article. You can listen to article, and then you will get an option. Where is it? Okay, it is not showing. But what happens is they offer you to collect their articles as NFTs. I'm not sure why it is not showing it like this. So this is an article and it is not showing an option, but it generally shows you an option to collect this article as an NFT. Okay, let's not waste time on it. Let's get on with the next topic, and we'll be wrapping up the session after that. So some important things what to remember are, let me just make a file. Yeah. Let's make the font size. Okay. So number one, important things to remember, that asymmetric key cryptography. Asymmetric key cryptography is used in blockchain. It uses two keys, one public and one private. Third, it is slower but much faster. Fourth, uh, the asymmetric cryptography hash values are much bigger 2048 bits to be exact versus a symmetric one which uses 128 or 256 bit crypto, sorry, 256 bit uh, 256 bit um, keys with maximum 8 parity bits. So we also covered ZK EVM rollup. We also created our wallet app and connected it with a DApp. So there are many kinds of DApps, such as oneinch.com, Aave, uh, Pancake Swap, I already showed you, eSwap, Sushi Swap, DYDX. There are games on blockchain, like the card game I showed you. There are many other card games as well. There is another website called, I'll show you. This website, tapradar.com. Okay, so there are a tons of dApps. This is your home project. Consider it your home project. Please do explore all of these dApps. There are games to discover. You can even play these games. These are mostly play to earn games. So some games will offer you NFTs to sell, like avatars or in-game items, or sometimes they will offer you tokens. So you can even play games and earn money, or you can list and create your own collections of NFTs to sell, or there are different chains. So this is the important part. I'll be covering this chains part and then wrapping up the session. So what are these different kinds of chains? So earlier we discussed about coin versus token, right? Uh, so a coin has its own blockchain technology, its own blockchain network, but a token is dependent on another's blockchain. For example, Shiba Inu is a token that is developed on Ethereum. So there is BNB chain, there is Ethereum's different chain, there is Polygon Matic, there is Tron, TRX. They all have different network system. So if you want to send cryptocurrency, make sure you are sending it in the to the right crypto network. I'll even write it down. So we covered the DApp radar as well. Eighth is, yeah, crypto networks. So what are crypto networks? Crypto networks are basically different kinds of networks that are used for transaction. If you choose the wrong network, you might lose your cryptocurrency forever. So it is very important to make sure you are using the right crypto network. So let me tell you, uh, crypto network for Ethereum is ERC20, NFT Ethereum is ERC 721, then BNB chain we saw is Web20. Then again, there is a TRX network. Then we have a USDT network. We have Optimism network as well, Arbitrum. So most of these layer 2 solutions are these they have their own network, and using their network uses less gas fees. So yeah, they are much better when using or transacting in cryptocurrencies. Okay, yeah. So with this, let's end the session for today. Please, please do research on DApps, decentralized applications, and I want you to be all interactive. I want you to all ask questions. Please do ask questions. Please do not hesitate to ask any question. Uh, Please do explore this DApp radar and set up your wallet app and connect with different types of decentralized applications. There are gambling applications. Do not use them. I'm just showing you. There are social applications. So these are social applications. So for example, Dmail network. This is a decentralized network for emails, so no one can decode it. So you can see different kinds of projects, and it might give you an idea of what you might be able to do with these kinds of projects, or you can get an inspiration for a new project. So please do research about these different dApps, and the most difficult part is DeFi. This is the most difficult part. If you can understand the DeFi system, ecosystem in blockchain, consider yourself already a master. You can start making good quality projects. So yeah, and my interest is in DeFi, and I love DeFi because I'm sure it is going to replace the current banking system completely. So yeah, thank you so much for giving me your time, and I hope this session was valuable to you. You understood the cryptography techniques used in blockchain technology. We also talked about the WhatsApp encryption and decryption method. Now you know about the secret key and how the ciphertext works. If you want, I can show you how to encrypt and decrypt uh, the ciphertext as well using tools. That is only if you want it, you can write it in the chat box. Otherwise, we'll just continue with our next topic, which will be consensus protocol. So we'll be covering all the consensus protocols and we'll be discussing them in detail along with the projects that use those consensus protocols. So yeah, thank you. Any
Okay.
questions?
Okay, guys, hope you enjoy the session. So, is there any queries? Please let me know in the chat box. And Namira is asking, Sir, I did not mark my attendance for the first day. Please, can you mark my attendance? So, 60% attendance is mandatory for the certificate. Okay. Okay, I hope there is no more questions. So, we'll meet on tomorrow. We'll wind it up for today. Okay. Yeah, thank you so much for your time.
Yeah, thank you so much again for giving me your time. And I hope I was able to clear everyone's concept.